So this is part 2 of Cobweb Diagrams and Sums of Infinite Series. Part 2, Cobwebs on the Inside. So this time we'll start with an isosceles right triangle, which basically just means a square cut down the diagonal such that two sides are the same. The difference from the last video is that this time we're going to draw the cobweb diagram on the inside of this triangle. So here's the other slope for the cobweb diagram. So we have Kn, No, Op, PQ, QR, RS, ST, TU, and of course all the way up on to infinity. We already know what Kn is, it's x, and we already know what No is, it's x. So what is OP? Just like in part 1 of the cobweb diagram videos, we can look for similar triangles. So we'll start off by noticing these opposite adjacent angles. We see that KL and OP are parallel, so that the blue double-ticked angles are opposite interior, and so they must be the same. Those are both 90-degree angles, and we can see that the green single-tick angles are the same. We can also notice that ON and ML are parallel, so we can see that those two triangles are similar. So we'll try to find some ratios to sides that we actually know. So let's compare here the sides circled in green. We have NO to OP, and that should be equal to the ratio of ML to LN. So now that we know that NO is to OP as ML is to LN, we can fill in some of those values. We see that NO is equal to x, and we know that ML is equal to 1, and that Ln is 1 minus x. So we have one equation with one unknown, which is the length of OP. So solving for OP, just by cross-multiplying, we see that OP is equal to x times the quantity 1 minus x. So let's just label that. To find the next side, PQ, we notice that those exterior angles, those angles on the outside of those triangles are all 45 because we started with KNO triangle, which had both sides equal to x, and there's a 90-degree angle in there, so that means the other two are 45 if those other two sides are equal. And because all these lines are parallel, the KN, the OP, the QR, all the way up, and the verticals are parallel, that all those are 45s. There were 45s in the other diagram, but they were facing the inside because the cobweb diagram was on the outside of that big triangle. So we know that OP and PQ are the same length, and that length is x times the quantity 1 minus x, and we'll just indicate that with a yellow line pointing to that side. So again, by similar triangles, using the technique in this video and the part 1 of the video, we can show that QR is now x times the quantity squared of 1 minus x. So it's increasing by 1 minus x each time, and we see that SR is the same as QR because that's also a 45, 45, 90 right triangle. ST and TU are the same, and it should be all the way up to infinity towards M. Just to emphasize this relationship of the three similar triangles we just looked at, we can see that NO is to OP as PQ is to QR, as RS is to ST. NO to OP is in red, PQ to QR is in blue, and RS to ST is in green. So if you watch part 1, you probably know it's coming. We're indicating all these horizontal pieces going up the cobweb diagram. Follow this progression where they increase by a factor of 1 minus x each time. So this time the cobweb diagram is inscribed entirely within this isosceles right triangle, but we're still going to add up all the horizontal lengths. So we see that the bottom length is 1, and that is going to be equal to x plus x times the quantity 1 minus x plus x times the quantity squared of 1 minus x plus x times the quantity cubed of 1 minus x, and on and on and on forever. So let's plug in some values and just see what we get at this point. So if x is 2/3, we're going to see the equation telling us that 1 is going to be equal to 2/3 plus 2/3 times the quantity of 1 minus 2/3 plus 2/3 times the square of 1 minus 2/3 plus 2/3 times the cube of 1 minus 2/3, and on and on and on. Doing those subtractions, we see that we get 1 is equal to 2/3 plus 2/3 times 1/3 plus 2/3 times the square of 1/3. So inside each of the parentheses is a third, and that's going to get cubed into the fourth, into the fifth, and on and on and on. When we multiply out the term inside of the parentheses, we see that we get 1/3, 1/9, 1/27, and that goes on. But at this point, let's take a detour while we have this equation handy. So far, we've been looking at line segments, which are one-dimensional in a two-dimensional plane. Now let's think about this two-dimensional area of a square. Using the same equation, let's look at a square of area 1 in red. Now split 2/3 of the square, leaving a remainder of 1/3, represented in green and blue. Now split 2/3 of that 1/3, which gives us 2/9, leaving a new remainder of 1/9. Again, split 2/3 of that, which is 2/27, leaving a remainder of 25/27. What did we do? We took a square of area 1 and we cut 2/3 of it. Then we took the remainder and cut 2/3 of that, and then the remainder, 2/3 of that, and the remainder, 2/3 of that. So this is one way to see that those fractions all add up to 1. That is, we take a square with area 1 and cut it up such that each successive piece has the area of the next fraction in the series. And that way we see that this finite square is made up of the infinite series of all these pieces. You can see the sigma notation down below the square representing the series. And that's that for the two-dimensional case. So for the finale, let's go back to this one-dimensional case of these horizontal segments inside the cobweb diagram inside of this triangle and add them up when x is equal to 0.9. Now, if x in the diagram were 0.9, it would actually take up most of the bottom. It would go 9/10 across, and there would just be 1/10 left over for 1 minus x. But let's just see where this goes. So 1 is going to equal 0.9 plus 0.9 times 0.1 plus 0.9 times 0.1 squared, and then the 0.1 is going to be cubed. So then when we square and cube all those values inside the parentheses, we get 0.1, 0.01, 0.001, and on. Multiplying by those values in the parentheses, you can probably see where this is going. We get on the right-hand side of the equation 0.9 plus 0.09 plus 0.009 on forever. That's right, the value on the right is 0.9999999 forever, otherwise known as 0.9 bar. That's right, so this was a geometric proof showing that 1 equals 0.9 bar, disguised as a video about sums of infinite series and cobweb diagrams. I hope you enjoyed it. Happy Halloween 2013.